Hello there, Avon High School College Algebra II students, or any of the students that might be watching this video on my YouTube channel. We are looking at our section 9.3, kind of talking about function analysis and looking at the graphs of functions and setting functions equal to values and inserting values inside of functions. So section 9.3, we're going to start looking here at examples 3 and 4. They're both very similar. They're just going to deal with two different types of functions, but the questions that they're centered around are going to be very, very similar. So if we read this, it says, for each of the following, use the given function and there is a word here missing, to find either the y value given the x value or the x values given the y value. So we're going to use this equation, but we want to verify your algebraic results by looking at the graph that's given. So we've got a sound sketch of this graph. So if we're asked to find the value of g of negative 6, well, that's just a matter of us taking that negative 6, plug it in for that x, and upon doing so, being very careful to deal with this absolute value correctly, we would end up with 4 minus 5, or negative 1. Now, if we look at the graph, when x is negative 6, lo and behold, we do have a y value of negative 1. That just reinforces that we did our algebra correctly. Finding the value of g of 1, done very, very similarly. We would replace the x with 1. Leave everything else be around it. This should be a minus. And then we have the absolute value of 1 plus 2, which of course is 3, positive 3. Once we subtract 5, we have negative 2, and lo and behold, when x is 1, the y is negative 2. Now, if we move the other opposite direction, it's typically going to be a little bit more challenging. For what value of x does g of x equal negative 4? So you're going to take this absolute value of x plus 2 minus 5. Again, this is the g of x expression. But now we set this whole thing equal to negative 4. And then in order to solve this equation, you're going to have to go way back to really the beginning of our class last year, or last semester for my students. Last year, if you're maybe a pre-calculus student watching this. And we're going to have to recall, how do we solve absolute value equations? And they all start the same way. You're going to get the absolute value alone. So you're going to add 5 to both sides here. But then, what we have to do with this is solve this by setting the absolute value of x plus 2 equal to 1, now without the absolute values, and do the same thing, take the stuff that's inside the absolute values, and set those equal to negative 1. Because that's basically what's going on with this. We can say that the quantity inside the absolute value can either be the positive version of the right side or the negative version of the right side. And then you pretty much see that this is going to result in two different x's. But that's certainly to be expected, because when y is negative 4, when the g of x is negative 4, we see that there are indeed two values of x that correspond to those two numbers, negative 1 and negative 3, that we just found. Same thing is going to happen potentially for d. We'll find out here. Absolute value of x plus 2, subtract 5, now equals positive 5. So if our first step is to add 5 over, we would have absolute value of x plus 2 to be 10. So in solving this, x plus 2 is 10, or perhaps x plus 2 is negative 10. Now when we subtract 2 over, in both instances, we have two answers, positive 8 and negative 12. Now, the problem with this is that we really can't look at this from a graphical standpoint, at least with the graph that we have right here for example 3. If you absolutely wanted to verify if this is going to be true, I can go ahead and take a look at a fresh graph, and I'll just get done one ready here on the Inspire. And if I remind myself, we're graphing absolute value of x plus 2 minus 5. So I bring up my math template. The absolute values is in the second row, first option. X plus 2. And once again, that was a minus 5, just to verify. there's the graph. And then I'm going to do a little trick here. I'm going to double click this guy. I'm going to make this guy go up a little bit higher. Maybe I'll make this guy go up to like 12. And that might do it. And then I'm going to go ahead and turn on my grid lines. Let's turn on those grid lines. So what we did in this problem is we wanted to figure out where are we for our x value when y is 5. So I know that my answers are supposed to be 8 and 12. Or I'm sorry, 8 and negative 12. Well, when I go up here 1, 2, 3, 4, 5 and across, it definitely seems like that value that I'm hovering on is an x value of 8. You can just count backwards from 10. Now over here, I don't quite have enough room to go up to 5, but maybe if I make this go out to, say, negative 13. Now this negative 13 does not correspond to that mark. The negative 13 is the far left side of the screen. It's a little bit of a, kind of a flaw, I think, sometimes in the Inspire, but this should be the negative 12 x value. You can count them to verify, but lo and behold, the y value is up here at 5. So we have a legitimate result here for example 3. All right, let's go ahead and do example 4 while we're here. Like I said, it's a very similar process. It's just that we have different operations that are going on. So if we're going to find h of negative 1, we are going to take negative 1, and we are going to substitute it in for the x value. So we'd have negative 2 square root of negative 1 plus 6 plus 3. Negative 1 plus 6 is, of course, positive 5. And then when we get there, we are stuck. We are stuck right there. We're not going to do anything. That is simplified. That is really as much as we can do with that. If you really wanted to see what that would be as a decimal, you would have to use a calculator. So I could plug in negative 2 times the square root of 5. I'm going to put a decimal after it. And then you need to finish it up with a plus 3, it says. And the decimal I get is about negative 1.47, pretty close to negative 1.5. Well, if we look at this graph, when x is negative 1, lo and behold, that y value is pretty darn right where it should be. But it's so much better to use this as the answer. All right? Especially if you don't have a calculator, you don't have much of a choice anyway. Now, if we check this second one, h of 10, we can go about our business much the same way. When we plug in negative 10 for x, not negative 10, positive 10. I was going to say if we plug in positive 10, that's okay, but if we plug in negative 10, we got a problem. So we're going to get this. Now the difference between these two answers is that this one's going to be a little prettier. The square root of 16, a perfect square, of course, is 4. So we would end up with negative 8 plus 3, which gives us negative 5. Now, unfortunately, we're not going to be able to verify that because we don't go out far enough to get to 10. Much the same way, I could throw this into the graphing calculator and show you that we would indeed get that particular result. All right, finishing up, let's take a look at part C. Now, what values of x would h of x be 1? So we're going to take the original function, h of x, here he is, and let's set him equal to 1. Now, as I said before, this one's going to be a little trickier than, say, part A or B. Your first step is to subtract 3 over, get negative 2, and then we're going to divide both sides by negative 2. And that takes us here. Now, to solve a equation with a square root, we would square both sides. The square of 1 is still 1. And then when we solve, we would subtract 6 over and get negative 5. Now what that means is the x value of negative 5 would have a y value of 1, and lo and behold, from the graph, you can see that that is indeed true. For our final one, same situation. For what value of x does h of x equal negative 3? So you would take the function and set this equal to negative 3. So you're going to subtract 3 over, so we would get negative 6. Divide both sides by negative 2. And at this point, you would square both sides to get x plus 6 is 9. So x is going to turn out to be positive 3. Let's take a look at the graph. When x is negative 3, I'm sorry, let's take that back. When x is positive 3, I'll get that right, the y is indeed negative 3. So you're just manipulating some functions. It's pretty basic. Really, just by looking at example 3 and 4, you really have the knowledge that you need. The examples 1 and 2 that preceded these two problems really are just setting up the same idea, and I think you're going to be fine to turn yourself loose and work on the homework. For my particular students, there will be a Schoology submission for this particular assignment, so just log on to Schoology when you're ready to submit, and the due date's all in your Schoology profile, and you can take care of that for me. But anyway, I hope this helps a lot, and I will see you next time.